Good evening, everyone. We are going to start the class. If anyone needs, yes, already recording permission, tell me, right? Before starting the class, if anybody needs recording permission, tell me. Right? Okay. Now today we have to discuss two lessons, actually, right? Not two different lessons, not totally two different lessons, right? But if you can remember in the past tutorial, that is tutorial number 14, we have to discuss about the past paper and textbook questions. We only discussed the revision part, right? So we have to discuss the questions in that one. I think all of you are here. That's why I took several minutes. Now all of you are here. So we have to discuss that part, and also we have to discuss today's lesson and tutorial. So what we are going to do is we are going to start the 15th tutorial. That means we are just going to discuss the 15th lesson and all the questions. That is a small one. So we can very quickly, not very quickly, but within the time we can finish most probably within 2 hours. After that, from 9 to 9:30, or after that, finishing the 15th tutorial, 15th lesson, we can discuss the questions related to the 14th lesson, right? So that is how the things are going to happen. Right now most of you are here. The others will join the, right, again, the others will join the Thursday class, right? Most of the revision students are on Thursday class, right? But no problem, right? Now we are going to start. Okay, so this lesson is easy, right? Comparatively to the other lessons, this is easy. So if you have any question, again, the new students, new means I know most of you are coming for the class regularly, but if there are any new students, now as you use the external microphone, you I cannot hear what you say, right? So send me a message through Zoom if you have any question related to the matters that I discuss. So if you have any question, right? If you want anything to be further discussed at the end of the class, I can allow you to talk to me, right? Okay, that is how things are going to happen. Okay. Now we are going to conduct the lesson as usual, right? So this one is easy. There are new. No, right. Most of you are here. Right, this is very easy, right? So we have initially talking about the hydrostatic pressure, but before coming to that, hydrostatic pressure and its application. But before coming to that, we just want to recall our previous knowledge. That is, what is pressure, right? Give me a second. Right. What is pressure? That is a very simple one, right? Very simple lesson, and you have been discussing that for a long period of time, grades 8, 9, right? So pressure means the amount of force that is acting on a unit area, right? So if we write P, pressure is the force acting on a unit area. You know this since grade 8, right? So you can get its Newton for force per meter for area. By the division or by the primary units, we can get the again Newton, right? Newtons per square meter. Newton per square meter is the unit for pressure. But we can use, we call this as the primary unit. We can get another unit. Most of the times we use that unit. That is 1 Nm minus 2 equals 1 Pascal. So no problem. Instead of writing Nm minus 2, you can directly write without any calculation or without any mathematical work. You can directly write Pascal instead of Nm minus 2. And also you can use convert Pascal into nm minus 2 if you want to make any calculation, right? That is a very good one. And how about now? Let me. Still the same question? All right, I'm going to continue. Comment me, right? Quickly send me a message, right? About the situation. No, mic working, right? Yesterday also the mic worked. Still, do you have that problem? Do you have that problem? Someone quickly send me the message. Still, do you have that problem with the microphone? Little bit. Others, how about that? No, right. If there is a question or if there is other microphone, or we can use the laptop microphone, no problem, right? If the question is again whatever, there is any distraction, quickly send me, right? Quickly send me the message. That is one reason can be due to this heavy rain, not here, but actually throughout the island there is a heavy rain, right? That can be another thing for the audio quality. But if you have any question, just like that, send me, right? I didn't. So whatever I discussed is to get the units very easy, right? Primary units are there. You can derive the other units from this one very quickly, very easily. You can derive. Give me a second, right? Right. We want to get some space here. So very easily we can derive. Right. Few of you are getting here now, right? Very easily we can derive the units, the initial units, primary units, and from that the secondary unit, that is Pascal. Those are very simple things, right? Which is not difficult things, right? Few examples are given here. I'm not going to talk about those things, right? We'll talk about them in the tutorial. Now let's go to the topic of this lesson, that is hydrostatic pressure. Hydrostatic pressure means all the liquids, right? Sometimes the air, but in this lesson we don't consider the air factor, right? We talk about the atmospheric pressure, no problem, but we don't consider air as a liquid or such things, right? So all the liquids plus air can apply a pressure on objects, right? So if we imagine a situation that we are going to deep sea, if you can remember, for when you're talking about some organisms, we specifically mentioned that they live in deep sea. Deep sea means again no oxygen, right? And no light. There are problems like that. Apart from that, high pressure is there, right? If you know about submarines, some submarines can go few kilometers to the deep sea, so they are with very tough, they are built with very tough metals in order to be in that pressure, in order to withstand that pressure. So you know that when you are going deep, right, when you are going down in a liquid, it can create a pressure, right? So let's see how it is created. So these few things, as this is a revision for those who are coming for the first time and those who are not coming regularly, right? When you are doing a physics one or when you are doing a chemistry lesson, the number of students increase. Biology and all the other things are also very important, right? Biology එකනොට එක එන ගාන අඩුයි එක පාඩම් කරලා බලා ගන්න පුළුවන් කියලා හිතනවත් දන්නේ. It's okay if you think that you can manage that one. But if you have any problem, especially in biology things, try to make short notes, right? අදෙන් අපි මේ කරනකොට totally 35-40 විතර ඉන්නවා revision class වල chemistry lesson එක, chemistry and physics lessons, right? But when it comes to biology lesson, it becomes 20-25 both classes together. So please concentrate on that one. Even you are not coming for the revision class, that is a problem, not a problem for me. But please try to manage that. Don't waste a lot of time on cramming these things in biology, right? I have specifically mentioned the methods that you should follow to tackle each of the questions and each of the theory, right? For those who are not coming, please make short notes. Right? Short notes is the key for biology lessons, especially in this time, as you are 3 months away from your examination, right? Okay. Again, Mikey के प्रश्न याद जाने हैं? हाँ नहीं नहीं. ये कभी पढ़ सकता है terms. Sorry. Right. Right, now we are going to quickly identify the characteristics of hydrostatic pressure. As this is a revision class, I'm directly going to the characteristics, right? Okay. According to the studies so far, give me a second, right? You don't need to look at the textbook, right? You don't need to look at the textbook. I'm just taking textbook just to see I am going out beyond, right? Okay. According to the studies so far on pressure due to the liquid, a liquid pressure has the following characteristics. The pressure at a certain point in a liquid depends on the height of the liquid column above the point. Pressure increases with the height of the liquid, right? Okay, let's quickly recall the first point, right? Let's quickly recall that first point. That means imagine I am in a place like this. This is a swimming pool, right? I am in a place like this, standing. So you can see, right? The water is filled. Several water molecules or water particles are on my head. It is just like, right? If I draw this column, if I take this column, it is not nicely drawn, right? If I take this column, all the water particles, so all the water molecules are just like situated on my head, right? If we forget this swimming pool thing, it is just like holding a water column on the head, right? That means that water column has a weight. Weight is generated due to the mass, right? That water column has a weight. Weight means a force. So force acts on my head, that is area. So a pressure is created. Simply, that is the thing, right? So with that, we can very nicely derive an equation for that. Let's go for that one, right? So this is the water column, right? So it has a weight. Weight is a force, should be divided by the area. This is how to get it. But it is difficult to get in this way because the dimensions are not that much appropriate. It is difficult for us to get the specific weight of the water column only acting on our head or only acting on that particular position. So we should be able to get some flexible units for that one. So we are going to do some changes for this equation. So what we are going to do, give me a second, I just want to check whether you can see the board. Right, you can see, no problem. So what we are going to do is weight. Weight is mg. mg divided by A. Now we can do something about m. Mass is density divided by volume. So instead of this one, I can write density divided by volume, right? I'll yes, I will instead of volume, right? Now you know the volume, you know how to get the volume, right? I'll simplify it here, right? Volume can be taken as area into height. So I'll directly take it, right? Otherwise, there's going to be a lot of calculations here. So mg should be divided by A, but instead of m, we are going to write rho. Rho, that means density divided by A h, right? So rho, right, you can see. Make a mark on anything, right? So, අපි මෙහෙම දාගමු. right? Okay. Is it clear for you? Rho equals mass divided by volume. So what I'm going to get here is mass. So mass can be written as mass is rho into V. That equals rho into A H. Right. Now I'm going to directly put that here. Instead of mass, I'm going to write this one. Rho A H G divided by A. Right. Can't balance. Right. Now, this was the initial equation. Weight. Weight was rewritten as mg. Now, this is m. This is g. This is a. Oh no, mayuka n. Right? Is it clear for you? Right. Now we can do a simple calculation. Sorry. A to A can be cancelled. So we can get the equation H rho G. Now we can get some flexible, or we can get some good units, or we can get some accessible units. We can very easily measure the height of the water column, or in most of the cases that becomes the depth. Imagine in a swimming pool, you are given the task to measure the water pressure at the bottom of the swimming pool. So you should get the depth, that becomes the height. H. Rho, this is rho, right? This is not P, this is a rho, that is a Greek letter. Just like alpha, theta, gamma, beta, likewise, that is rho, right? Rho is the density of water. G is the gravity. So you know all the units. Just by the height, we can know, or we can identify the pressure, hydrostatic pressure, or the pressure created by the water column. So with this, we can very easily see. Again, I'm going to rewrite everything, not everything, actually, this one, right? Minamika, you should be able to identify this one, because this is very important in MCQs, right? In MCQs, without doing much of a calculation, you can very easily identify this one. So pressure is H rho G. Now you know that rho is a constant for any liquid. For water, there is a constant. G is a constant everywhere on earth. So pressure only increases or decreases, or pressure depends only on the height of the particular liquid column for any particular liquid. Any particular liquid. If we change the liquid, if we go from water to coconut oil, water to another oil, right? Again, message mami. Area කියන එක ආපුදී ප්‍රශ්න ළමයි ඒකට is it a problem? Area ගැටලුව නේ. So whatever the area means, දැන් අපි අර සිලින්ඩර් එකක් වගේ හිතන්න. ඒකයි මම සිලින්ඩර් එකක් කියන්නේ, that's why I purposely draw cylinder, right? අපි වොලියුම් ගත්තයි same area එකකටම තමයි අර weight එක ඇඩ් කරන්නේ, right? එහෙම තමයි area divider cancel කරන්නේ, right? That means the same area. अब මගේ මේ ඔළුව උඩ තියෙන water column එකේ bottom එක. එහෙම නැත්නම් that area is the same area where the weight is acting on. Right? Area එකම තමයි ගන්න අපි volume එක කියලා ගන්නකොට. Just imagine that you are holding a cylinder on your head and your head is flat. ඔළුව flat කියලා ගන්න. එතකොට හරි. Okay. So the pressure depends on height when it is in the same liquid. If you are in a swimming pool, right? If you increase the height, if you increase the depth, the pressure increases. If you are going to move to another liquid, when the density increases, the pressure increases. When the density decreases, the pressure decreases. Try to identify those things with this equation, right? That's all. Because in some things, the nice comparisons are given, right? Someone is in a coconut oil, someone is on water, something is on another liquid, densities can be given, right? So when the density is high, definitely the pressure is high. That is obvious, right? When the density is high, the weight it is going to apply is high, so pressure is high. Very simple, right? So those are the relationships important in MCQs, right? First thing is, okay, first theory, right? Pressure increases with the height of the liquid column. I think that is clear for you now, right? නෑ පිරමිඩ් එකක් කියලා ගන්නවා පිසු. එහෙම ගන්න නෑ. පිරමිඩ් වල උඩ තියන් ඉන්නවා කියලා ලික්විඩ් කොලම් එකක් there is every time ලික්විඩ් කොලම් එක මෙහෙම තියෙන්නේ. හරි. කෙලින් තියෙන්නේ සිලින්ඩර් එකක් විදිහට තමයි ඇක්ට් කරන්නේ. right? 3 dimensional විදිහට හිතුවොත් සිලින්ඩර් එකක් විදිහට තමයි ඇක්ට් කරන්නේ. මෙහෙම තියෙන්නේ. ඒකට අනිත් water molecules ටික කොහොමද තියෙන්නේ? ලික්විඩ් එකට එහෙම ඉන්න බෑ. හරි. පිරමිඩ් එකක් විදිහට ලික්විඩ් එකට ඉන්න බෑ. liquids cannot be like that. right? ලික්විඩ් එකක් මෙහෙම තියෙන්න බෑ. ඊටු ටික මොනවද තියෙන්නේ? මොකුත් නෑනේ. ඒව solids නම් තියෙනවා. right? so for hydrostatic pressure මෙහෙම එකක් හිතන්නේ එම් පහර. මොකට එහෙම හිතනවද මන් දන්නේ. මෙහෙම I consider the cylinder like this because I am in a liquid like this. Whatever the things on me is on a cylindric shape, right? මෙහෙම හිටින්නේ liquids කොහොමද මෙහෙම ඉන්නේ? පිසුද? right. right. The pressure at the same level of a liquid is same. Now you know, right? Pressure at the same level. Now you had practicals and lot of things. Now as is a revision, I'm not going to do all the practicals and everything. I'm going to go through this equation. Pressure at the same level of the same liquid, it should be, right? Pressure at the same level of the same liquid. So if you can remember the practical, nice graphs and everything is given, right? When we take a balloon and put something over, take a bottle like this, right? Bottle එකක් අරගෙන මෙහෙම same level එකේ holes හැදුවට පස්සේ එකම දුරට තමයි මේවා වැටුනේ. ඕවා නිකන් චූටි practical. හරි. Those are just primary practicals, right? We are going to go through the equation here, right? Now see again at the same level rho is same, right? G is same, height is also same, right? But it should definitely be for the same liquid, right? If the liquid changes, you can very easily identify pressure changes, right? Rho changes, pressure changes. Liquid එක මාරු වුණොත් pressure එක මාරු වෙනවා. මෙතන කියන එක specifically ඒගොල්ලෝ කියලා නැහැ. It is A level physics වල තමයි අපි stress කරන්නේ. The pressure at the same level of a liquid කියන නිසා සමහරට ළමයි එහෙම හිතනවා කියලා හිතන්නේ. But it should be හරියටම ලියනවා. The pressure at the same level of one liquid or the same liquid. Same level of the same liquid. එතකොට is the same. So same වැඩි වෙන එක කැතනවා කියලා හිතුවද but it should be right. A liquid කියන එක එකක් කියලා ගන්නත් පුළුවන් but most of the time students don't think in that way, right? The practical was like this but it is not asked for the examination. What you should get is to the equation. මෙහෙම තමයි ගන්න පුළුවන්. All the constant are equal at the same height. H, rho and G. So definitely pressure should be equal. එහෙම තේරෙන්න ඕන. හරි? At a given point in a liquid the pressure is same for all the directions. That you already know that, right? Pressure is same for all the directions. Liquid pressure depends on the vertical height of the liquid column. It does not depend on the shape of the liquid column. Yes, right? It doesn't depend on the shape of the liquid column. Then I upset කරගන්න එපා මොකද්ද කියලා, right? It is like this. Shape of the liquid column means pyramid දරව මෙහෙම හිතන්න එපා. Right? Now different shapes are given. යන්න ඔයගොල්ලෝ දීලා තියෙන shapes වල graph that is activity 15.1 page number 66, right? In that one you can see different shapes are given, right? Different shapes are given. I am going to draw them and I'm going to just show them that there is no effect from the shape, right? It is like this. Let's take the first shape, right? First shape, it is like this. I'm not going to draw the exact one, but it's like this. Next one, it is just like this. Next one, ouch. And let's take the this one. The other one is simple, right? Whatever the shape. So what happens in each of the position? Right. So what happens in each of the case? If we take this one, this point, I think you can see clearly. Regardless of the shape, what matters for this particular point is the things above that one. So what matters for this point is this column. For this one, this column. For this one, this column. For this one, very interesting, right? It should be like this up to this point. The rest should be covered by this and like this. The rest is covered by this. Actually, in these things, right? In A levels, you are going to learn it is not a direct pressure acting on this one. What we call this one is an angular pressure, right? You don't learn about these angular pressures, right? So from these things, an angular pressure is acting. So the collective of the angular pressure again acts as the same one. That's why we're not going to do any calculations here, right? Again, you can get the trigonometry, sine, cos, tan, and very easily prove that the angular pressure acting, when we take the angular pressure collectively, the pressure is equal, right? But what we are going to express here is the shape. Here you can see a lot of things, or a lot of matter in this one, whatever the liquid. But that doesn't affect the pressure here. That affects the pressure in these places, right? That pressure affects in these places, but same here, right? For a specific point, right? For a specific point in different shapes, the shape doesn't make any difference, right? Shape doesn't make any difference, because whatever the thing's effect is, the molecules or particles or liquid or whatever above that particular point. That's all, right? Okay. Another question. Yes, the pyramid එකක් අදලා තිබ්බොත් එහෙනම් pyramid එක කියලා මේ වගේ ඉන්නේ. මේ තියෙන pyramid එකක් වගේ. එතකොටත් මෙහෙම තමයි තියෙන්නේ. ෆීල් කරන්න මේ විදිහට මෙතනින් උඩ තියෙන ටික තමයි තියෙන්නේ. right? ඔච්චරයි. මෙතනින් උඩ තියෙන්නේ. right? Pyramid එකක් වගේ තිබ්බත් whatever finally acting is a cylinder like structure, right? For a specific point එකට තමයි pressure එක ගන්න අපි. හරි? For that one, whatever the particles above that one, that's all. Particles above that one can only be in the cylindric form. Cylindric form එකේ විතරයි තියෙන්නේ. වෙන shapes වලට ඉන්න බෑ. හරි? මෙහෙම තියෙන්න බෑ. Just imagine as is a liquid deck නිසා. හරි? Right. Okay. Now let's quickly go to the rest of the lesson. Right. I think that is clear for you. Now the equation is given, right? But I like if you can go for these previous theories or the previous things that we discussed through the equation. පස්සේ test කරන්න ඒක තමයි, right? MCQs වලදී ඔය ටික කටපාඩම් කරගෙන යන්න ඕනේ නැහැ. You can just go through that one through theories. Theories වලින් equation එකෙන් තමයි ඔය ටික prove කරන්න බලන්න, right? In this one, පොඩි lesson එක පටන් ගන්නකොටම ඒගොල්ලෝ චිත්‍ර ටිකක් ඇඳලා just they have given some diagrams, several practicals, very simple, right? Not laboratory practicals. ඒවා lab එකේ practicals නෙමෙයි, හරි? බෝතලයක් මෙහෙම විදලා එක එක තැන් වලින් වතුර යනවා බලන එකේම very simple, right? So what is finally getting is this equation. Through this equation, with this equation, you should be able to prove these assumptions, right? I think that is clear for you, right? And there are exercises. I'm not going to do exercises here. Let's do the exercises at the tutorial. Tutorial exercises, right? Next one, transmission of pressure through liquids, right? This is a nice topic, right? Transmission of pressure through liquids. අපි ඉක්මනට ඒකට යන්න. කරලා ගන්න. Right, now we need to transmit pressure from one place to another in several incidents. We need to transmit the pressure from one place to another in several incidents. We are going to talk about a lot of examples. One good example is now, earlier in most of the vehicles, we used, earlier means before 1975, let's say 1980, right? Cable brakes, right? Cable brakes. That means just like I think most of you and all of you may have at least seen a food cycle, right? A food cycle. In a food cycle, there are cable brakes, right? There are small cables, so they get dragged on, right? Due to that one, small brake pads will initiate some pressure on the wheel that is going to stop the wheel, right? That cable brake is good, or that cable brake is sufficient for only small momentums. Now I can use the term momentum, right? So if you take a lorry, right? If you take a container, even a very tough cable cannot withstand that pressure that is, or withstand that force, right? In Sri Lanka, most of the times when people are going down Kadugannawa and Galagidara, those slopey places, right? Most of the vehicles got with accidents due to this losing of brakes. We call it brakes are going to be loosened, because most of the times, right, even if these cables are not maintained well, they are going to be broken, right? They are going to be broken, right? Detached. So it was a huge problem. So then scientists tried to identify a method. As a result of that, they came up with the hydro or whatever, using a liquid to get the brake, right? Later names were changed and hydraulic brakes term came, but hydro means whatever, using a liquid, hydraulic brake. And that technology was used for a lot of things, right? Hydraulic pressure incident was used for a lot of things, right? One example was given, uh, that brake thing, right? But people identified that we can transmit pressure. That means I can apply pressure here and get a work done in another place through sending pressure in a liquid, right? I can apply the pressure here and get a work done on another place while sending the pressure through a liquid, right? The advantage of this one is there are no breaking down and all several problems which occur when we are trying to transmit through solids, right? When you are trying to transmit through solid, there are several problems. Let's discuss them and see how we can overcome them with liquids, right? Food cycle and bicycle. We don't say, right? For motorbikes, yes. But food cycle is whatever the one which we operate. Bicycle term is commonly used for all, right? Motor bicycle, motorbike, right? That differs. That is English, right? Okay. Now, that is why the transmission of pressure through liquids is important. Now, this is how it is going to happen, right? So, what we are going to do here is we are going to apply a pressure at one point and we are going to get a work done at the other point. So in this one, additionally, we can get a higher force. Highlight this, but I can talk to you about this work and everything as this is a revision, right? Now you may be thinking, when we are applying 20 newtons, how come we can get 400 newtons at one point? Is the energy going to be reproduced here? Energy right? Energy cannot be destroyed and energy cannot be reproduced. Right? What we are doing is energy conversions on Earth. Energy conversions, right? We cannot destroy energy or we cannot reproduce energy. Right? Okay, but there is one point. In atomic bomb, energy is reproduced actually, right? One energy is given, that is an extreme incident, right? Apart from that, we cannot do this. So how 20 Newton is going to be converted to 400 Newtons? Let's talk about it later. First, let's talk about what is important here. That is how the liquid is going to transmit pressure from piston A to piston B, right? Quickly, I'm not going to draw it nicely, right? Because it is given clearly in your one. So please refer your one, right? Okay, it is like this. There's a piston like this. Piston like this. Right. Let's see, this is a place where vehicles are repaired, service station, right? A vehicle is here. Now, whatever vehicle, right? Okay, the vehicle is here. Now, what we are going to do? Let's see what are the requirements, right? Now, imagine there's a vehicle there. So, what we have to do is we will have to apply. Imagine now, usual vehicle weighs somewhere around 1,000 kilograms. That means 10,000 newtons the force. So we will have to apply 10,000 newtons to lift it in the other place. And you know how difficult it is to apply 10,000 newton from a human feet, right? So it is very difficult to apply, right? So what we are going to use here is we are going to use different diameters here, and we are going to increase the pressure that is taken or given from the point B. This is point B and point A, right? Right. So this is what we are going to do. Imagine the maximum pressure that we can use here is 20. I'll take the values given here, right? I'll take the values given here. 20 Newton. This is the maximum pressure I can give, and I need to lift something which is 40 kilograms. That means 400 newtons. I want to get 400 newtons here. So I should set my setup. This is setup, right? this U-shaped thing is a setup. In a way to match that thing, I can change the area in these two places. Then in a liquid, you know that in a liquid, the pressure is same, right? Pressure is same, and we are going to neglect the height effect here, right? We are going to neglect the height effect here. We have neglected that effect. So what is the assumption that we take here? Very important, right? The pressure, the pressure. I'm going to take a different color and write it. The pressure applied here, P1, is acting on every place. Now you may be thinking, what happened to the height? We neglect that thing, right? Again, if we take it here, the height is going to be cancelled off. The මෙතනත් එකම height එකෙන් තියෙන්නේ. Liquid at the same level. හැබැයි මෙතෙන්දිත් අපි නිකන් assume කරනවා same කියලා, right? Okay. So it is P1. I can write P1 at both places. In this case, there is no trouble, right? No assumption. මෙතන assume කරන්න ඕනේ. Same liquid, same height. So the pressure is obviously same. So whatever the pressure I am applying here, should be coming here. So I'm going to write PA and PB, right? So my theory is, or my argument is, PA, I go to the other color, PA equals PB. This is my argument. Should be equal to PB, right? So let's try to write the pressure A, right? Area sabbala megulu dila tiyena. Another question. Yes, P කියලා කියන්නේ pressure තමයි. අම්මෝ මගේ එක ඇදයි වගේ පේන්නේ. චුට්ටක් නේ හොඳටම ඇදයි තමයි. ඔය ඇදයි. හරි. මම එක කිව්ව මම හරියට අඳින්නේ නැහැ කියලා. හරි. ඒක හරි අමාරු ඇයිඩෙන්ටිෆයි කරගන්න මෙහෙම. දැනුත් පොඩි ස්ලෝප් එකක් තියෙනවා. හරි. කෙලින් අඳින්න බෑ. right. අර ඉන්නවනේ අර සූරපප්ප කෙනෙක් බලලා දෙනවද ඔයගොල්ලෝ? චූටි කාලේ you may have seen. ඒකේ ඉන්නවනේ අර බාස් කෙනෙක්. කෙලින් වැඩ කර අන්න ඒ වගේ කියලා හිතන්න එතකොට හරි. right. කෙලින් අඳින්න බෑ එහෙම තමයි. හරි. right. okay. is this one, right? අපි මේකේ දෙන values ගන්නවා, right? කෙලින් ඕනේ ඔක බලා ගන්න. හරි. එහම චුට්ටක් කැමරා එකෙත් පොඩි ඉෆෙක්ට් එකක් තියෙනවා. හරි. ඔන්න ඔච්චරයි. right. හරි. දැන් හරි. PA pressure A මේගොල්ලෝගේ values ගන්න යා. 10 centimeters. 10. Here this is 200, right? Now you may be thinking, what is the problem with square centimeters? In this case, please remember, right? In this case, මේවා exam එකට වැදගත්. As this is a revision, highlight in somewhere and write it, right? When you are doing this one, you don't need to convert these values into square meters. Convert කරන්න එපා. ඒකට කාල නාස්ති කරන්න එපා. Don't waste your time to convert these values. In order to pursue you to that one, එහෙම කරන්නම කියලා මේවා දෙන්නෙම square centimeters වලින්. හරි? ඒතකොට ළමයි මේක බෙද බෙද ඉන්නවා. 100 into 100 වලින් divide කර කර වෙලාව නාස්ති කරනවා. You don't need to do that because later these things are going to be cancelled off for each other, right? හැබැයි please remember, right? Again one thing, if one is given in square centimeters and the other one is given in square meters, you will have to convert one. හැබැයි එච්චර අමාරුයි දාන්න නෑ O levels වලට. හරි? But please, if due to any reason such thing has happened, you will have to get them to one unit, that is according to whatever it is comfortable, right? For this one means only for the transmission of liquid pressure, that is for this structure. You can see these things are nicely going to be cancelled off, right? P1 equals PB, so PA, let's write PA 20 Newton divided by 10 square centimeters. I'm just writing with small letters because I have to space assume get some space, right? I'm going to write x Newton, whatever the value that I'm getting here, right? X Newton divided by 200 square centimeters, right? So you can very easily get x. This is mathematics, right? X equals, right, 20 divided by 10 into 200. 20 divided by 10 into 200. So that you will see these units are nicely getting cancelled off, right? So we can get the value 400. Right, this is the case. If we want to get 500 here, if you want to get 500 newtons here, if I want to hold something that is, let's say, 1000 Newton here, I should adjust the areas here. That is how I can hold something. Or if the areas are fixed, I can measure if I apply 20, how many newtons I can get. So any variable can change. Right? Fix කරපු මේ equipment එකක් නම් මට calculate කරන්න පුළුවන් මම 20ක් දැම්මොත් මට කීයක් හම්බ වෙයිද. Like that I can calculate if I apply 40 Newton, what is the maximum amount of not pressure, force applied to the other direction. එහෙම calculate කරන්න පුළුවන්. ඒව තමයි ගණන් වලට දෙන්නේ. හරි? So anything, please be ready. This is the way to do that. හරි? So you may be thinking the question. On දැන් මෙතනින් මේක ඉවරයි, right? The question, how this 20 became 400 here? 20යි මෙහෙන් දැම්මේ only applied 20. එහෙනම් මේක මාරුනේ. හරි? මේක මාරු මෙහෙම කරපුවා 20ක් දැම්මම ඒ පැත්තේ 400ක් එනවා. කොහොමද, how did that rest 380? The other 380 was coming. That is, if you can remember the work, W equals Fs at home, please recall that one. The distance that we have to push this is way higher than the distance that this get pushed up, right? The distance is actually into that ratio, right? 20 is to 400, the reverse ratio, right? So 40 to 20 to 1 ratio, 20 to 1 in this case. If we push this piston 20 centimeters, the car or whatever the other piston will only be pushed for 1 centimeter. So the work done is equal. That is how the 20 is converted to 400. ඔක ගොඩක් ළමයි තියෙන ප්‍රශ්නයක්. හරි? ඔබ දාලා කල්පනා කරලා බලන්න. සමහරව නිකන් තාලෙට වගේ හදාගෙන යනවා කිසි ගැටලුවක් නැහැ. දන්නෙත් නැහැ මොනවද හදන්නේ කියලා. නිකම් මේක මෙහෙම තියෙනවා. ඊට පස්සේ හදාගෙන ගිහලා උත්තරේ තරන ඔක්කොම කරනවා. But some students tend to think, right? What is happening here? How this 20 is converted to 40? ඒක කියලා තියෙනවා ලාභට කියලා තියෙන පොතේ. හරි? So this is how it is converted to 400. I think that is clear for you. This is used in many occasions, right? Right. Is given one incident is given here to lift vehicles, right? All things, but ඇත්තටම දැන් when it comes to real world scenario, what we do is we don't push it like this. මෙහෙම කර කර ඉන්නේ නැහැ. මේකට hydraulic එකකින් liquid pump කරලා වෙන technology එකක් use කරනවා. ඒකත් පොතේ දීලා තියෙනවා. It is given in the book, right? But අපිට ඒකෙන් වැඩක් නැහැ, right? Real time scenario we don't need, but what we want to know is pressure can be transmitted like this. The most important thing, PA, whatever the P here, PB, PA equals PB. That is the argument. With that we can build these things and equate these things, right? And also you don't need to waste your time on converting whatever the unit to square meters, right? They get cancelled off. Right. ගොඩාක් examples දීලා තියෙනවා. ඔය ටික බලාගන්න. හරි? Dentist chair is such way, right? Such equipment. Dentist apply a small amount of pressure, right? We can use this setup for that one because a man's weight is not that much, right? And also another man can very easily do that, right? It is a very easily lift. We can apply this one, right? I think it is clear for you. Any question? Any question from this one? No. Right. Right. No questions. I take one question.
I don't know that one accurately. Sigiri incident, right? Sigiri ki him kohomada.
Yes, but water is taken upward, right? Water is taken upward, but that is due to pressure we can do it. Definitely due to pressure we can do it, right? But the water source should be in higher place. That technology is not that much. I don't know how. Yeah, but still we don't know how the water was taken up, right? Using that one. But in simple physics, what should happen is the water source should be above. Water source එක උඩින් තියෙනවා. ඒක තමයි මෙහෙම අරකුලට ආපහු යන්න පුළුවන් වෙන්නේ, right? That is a simple thing. Yes, with the pressure පුළුවන්. Pressure එකත් එක්ක if we can generate high pressure, we can press that water upward. නිකන් සාමාන්‍ය අපි අතේම අපි if we keep let's say we are going to take a high pressure balloon, or we're going to fill water to a balloon, right? And we are going to make a hole, and you will see water is quickly going upward, right? That is one way, right? That is the technology actually they have used, assumed to be used in these ponds, right? In ponds you can see small is using, and also that is the thing that used in most of the natural ponds. If you have seen that nice water work in Kuala Lumpur, Malaysia, right? That is also due to pressure. The pressure, these things going to spread everywhere, right? Okay,
Right. So then let's go to the air pressure quickly. The first activity 15.2, I'm not going to discuss it, right?
It's a very easy one. What you're going to take is a YouTube, right? YouTube means not that social media YouTube, glass tube in the shape of U, right? And you are going to put water to the X and Y bars, columns, and then you are going to fix a gas balloon. That means a balloon blown by someone, and you're going to fix it, right? After fixing, you can see the bars which were in the same level at the B situation, right? The whatever the side which the balloon is fixed, the water level goes down, the other side water level goes up. So how the water level went down? Due to the pressure generated by the air. You can do the same by blowing to the air also, right? Hold them out and blowing to the air, so you can see water level goes up, right? So same thing. So that generally means, right? Generally means air can apply a pressure. Air, right? Air and gases, okay, හැම පාඩමේදී ඕන වෙනවා, right? Gas means a specific element. Oxygen, nitrogen, hydrogen, helium, likewise. Noble gases, likewise, right? Air means a combination of gases. It can be 2, 3, or many more, right? Air. එකයි water, sorry, gas and air කියන එකේ තියෙන වෙනස, right? Right. Then again we are coming to an important part, that is atmospheric pressure. I think again make a hurry lazy, but I will finish this barometer thing also here, right? How to measure and everything, barometer, everything I will finish here quickly. I think this is clear for you, right? Clear. ඊට පස්සේ අපි පොඩි break එකක් අරගමු. Then let's go for the tutorial to discuss the questions. මේක ඔක්කොමම කියවගෙන යන්නේ නැහැ. එතකොට තියරි ක්ලාස් එකක් වගේ නෝ අපිට එතකොට ඉවර කරන්න වෙන්නේ නැහැ රිවිෂන් එක කවදාවත්. මේකේ ගණන් අහන ටික විභාගෙට අහන ටික, right? These important things are discussed here, right? Okay. Now atmospheric pressure is just like the water pool or swimming pool situation, right? We are at the atmosphere. Now you can take all of you as examples, right? So air particles are above us, but the density of air particles, so the densities of air is very low in comparison to water, so we cannot feel it in that way, right? But there is a pressure, so that is acting on us. So again, just like the liquid, air creates the pressure on us. We can use the same equation, right? If we take earth like this, earth, and I am here, and this is the atmosphere, right? Atmosphere. So we can calculate the pressure generated by the atmosphere like this using H rho g, no problem, right? Using H rho g. So with this, පස්සේ එකට මේක ඕන වෙනවා, right? මේක that's, remember it this way, right? Later, there are some MCQs and all those things. When the height is increasing, if I am going to go from Colombo to Nuwara Eliya, what happens is pressure decreasing or increasing. I nothing to think, right? Imagine in this way, when I am going here, going up, definitely height increase, right? Height is taken as a depth, right? This height. When I am going up, what happens is height is decreasing. So definitely the pressure should be decreasing. So when I am going from Colombo to Nuwara, what happens is my elevation goes up. Elevation goes up means the distance between the outermost level of the atmosphere and me becomes lower in comparison to Colombo situation. So whatever the amount of air particles on me is comparatively low. So the pressure is low. Atmospheric pressure is low. If I go to Himalaya or Everest, right? Again, it is going to be very low. Likewise, right? Again, I am going to go, if I am going to go above or beyond the atmosphere, it is going to be zero. Like this, right? Okay.
Excuse me, sir. Excuse me, sir.
No questions, right?
Excuse
Now
me,
let's
sir.
see. I think that is clear for you. Now let's see the barometer incident, right? Taking this incident and the liquid pressure incident both together, we have created an equipment, simple equipment, or we can create at the laboratory to get the liquid pressure, right? Or to measure the atmospheric pressure, right? So let's see how we are going to do this. We specifically take mercury because if you are going to take liquid as water, so water as liquid, you will have to take a long tube because the height is going to be very high. We are going to take, the requirement is an a liquid with a very high density. Density එක වැඩි වෙන්න height එක අඩු වෙනවා because a multiplication is the pressure. දැන් මෙහෙම නෙන්නේ මේකයි හරි. ඔය මතක තියාගන්න ඕව තමයි exam එකට අහන්නේ හරි. P equals H rho G. So if P is going to be reduced, sorry, rho is going to be reduced. Rho එක අඩු වුණොත් ඒක අල්ලගන්න වෙන්නේ height එකෙන් තමයි, right? We will have to cover that from height because G is a constant, right? So what we do is we get a liquid with a very high density. So height is going to be a small one. නැත්තම් මේක meter ගානක් උඩට යන්න පුළුවන් height, right? එතකොට it is difficult for us to measure. That's why we specifically take mercury, the liquid with the higher density, right? Okay, now let's go for the way of working with the barometer. This is how we form it. Very easy. Take a trough, T-R-O-U-G-H, trough, and fill it with mercury like this, and take a test tube and fill it with mercury. එකත් ඇදයි නේ. හරියට. ඒක නම් කැතයි එහෙම තිබ්බම. මම ඉක්මනට අදින්න යන නිසා තමයි මේ ටික මේ වෙන්නේ, right? මේවට බොරුවට වෙලාව නාස්ති කියලා වැඩක් නැහැ. මේ කෙලින් තිබ්බා එහෙම කියලා, right? Okay. දැන් හරියට. So what happens here is, now let's try to identify or put all the theories that we learned here, right? Work with me and tell me the examples, right? Tell me the things, right? I want pressure here, PA, right? And I want pressure here, there is PB, right? Tell me the pressure at, one message is there, give me, right? Tell me the pressures. Try to identify the pressures at A and pressure at B quickly. මොනවාරි මයින් අහනවද ඔයගොල්ලෝ? මේක හරියට මොකරි කවුරු හෙව්වද මොකරි? මම කලින්ම ඉන්ෆෝම් කරා මේ කියන ඒවා ඇහෙන්නේ නැහැ ඔයගොල්ලෝ කියලා. කවුරු හෙව්වද මොකරි? ප්‍රශාන්ත් කවුද හෙව්වුණා?
සර් මම හෙව්වා.
කවුද?
මම හෙව්වේ.
ලෝක කලින්ම කිව්වා. මොකද කිව්වේ?
සර් මේ අර ඇට්මොස්ෆියරික් ප්‍රෙෂර් එක හොයනවා කිව්වනේ අර ඩෙන්සිටි මොකක්ද අර හයිඩ්‍රෝස්ටැටික් ප්‍රෙෂර් එක ඉක්වේෂන් එක දාලා.
ඔව්.
ඒකේ ඩෙන්සිටි එක මොකක්ද ගන්නෙ?
එයා එකේ density. එයා එකේ density. හරි. එයා කියන්නේ අපි atmospheric combination එක දිනවනේ. nitrogen 78%, oxygen 22% කියලා අපි ඔය ඉගෙන ගන්නවනේ. ඒකේ density එක තමයි දාන්නේ. හරි. තේරුණාද?
කී ඩෙන්සිටි
ඒකේ density එක specific value එකක් නෑ ඇත්තටම. හැබැයි පොඩක් ඔයලා round about value එකක් හොයාගන්න පුළුවන්. ඒකේ density වෙනස් වෙනවා තනින් තන. හරි. oxygen වලට density වෙනස් වෙනවා. nitrogen පොඩක් ගෙහිම වෙනොත් density වෙනස් වෙනවා. හැබැයි නිකන් ගහලා බලන්න හොයාගන්න පුළුවන්. හරි මාත් හරියට value එක දන්නේ ඒක එච්චර වටිනා එකක් නෙවෙයි. හරි අපි සාමාන්‍ය එක දාන්නේ මොකද වෙනස් වෙන හින්දා. හැබැයි average value එකක් කොහේ හරි ඇති. හරි. එහෙම දාලා ගණන් හදන්නේ අපි. හරි. එහෙම දාලා ගණන් හදන්න නැති වෙන්න හේතුව තමයි අර ඒක තනින් තන වෙනස් වෙන නිසා. හැබැයි අර concept එක තේරුම් ගන්න ඒක ඕන වෙනවා. It is very essential to identify that concept. හරි. ඒ කියන්නේ කන්දක් පුරනකොට ඒ ප්‍රෙෂර් එක අඩු වෙන්නේ. පල්ලනකොට ඇයි ප්‍රෙෂර් එක වැඩි වෙන්නේ. ඒ concept එක තේරුම් ගන්න ගොඩක් ඕන වෙනවා. That has been question, right? හරි නේද?
thank you sir
Right. H rho G, when you are putting that, if you have any question, please send me a message, right? මම කලිනුත් කිව්වනේ නියමිත මුලිනුත් හිටියන්නේ. මේ I cannot hear you, right? මට ඇහෙන්නේ නැහැ ඔයගොල්ලෝ. මේක දාලා තියෙන නිසා, right? එහෙම කියලා පිස්සුනට නෑ මම මයික් එක පේනවා හැබැයි, right? Right. PA, PB, I think you have identified. Now, මේක ලේසිනේ. මෙහෙම අනිත් පැත්තට හැරුවට පස්සේ what you're taking a fully filled tube with mercury. After this is allowed to settle, මේක settle වෙන්න දුන්නට පස්සේ චුට්ටක් මෙතනින් පහළට බහැලා යනවා, right? But in this case now here there is nothing. මෙතන මොනවත්ම නැහැ. එයා එකේම නෙවෙයි. There's nothing. So we call this as vacuum. Vacuum එක තමයි මෙතන තියෙන්නේ, right? It is nothing. We took a fully filled one and the liquid level dropped a little. So what is here is vacuum. So let's get the pressure A. මට කියන්නේ pressure A එක here. Pressure A. කියන්නේ you tell it to yourself, right? PA equals H, this height. Height rho, I'm going to put simple M, rho mercury. Mercury is density and gravity. H rho G, right? If we take PB is this point or any point here. So PB, if we take this point or whatever this point, the pressure acting on it is the atmospheric pressure. I'm taking the upper layer of this liquid, right? Upper layer, whatever the pressure it is atmospheric pressure. So PB, I'm going to write PATM, atmospheric pressure. And the next theory that we learn, at the same level of a liquid, the pressure is same. So you can see PB and PA both are at the same level. PA and PB both are at the same level. So PAB should equal to PB. PA equals PB. So ultimately PB means PATM, right? PATM equals H rho G, right? H rho G. The thing that I mentioned you earlier, if you use water, this height of the water column becomes very high, which is very difficult for us to even measure, right? So when we use mercury, that becomes very measurable, right? Hari. එහෙනම් කොහොම තමයි ගන්න. Take a look at this for a second, right? බලන්න වෙලා තප්පරයක් කරගෙන, this is very important, right? So this was the earlier technology that we used to measure, right? So people used to give the measure, to give the pressure value as a height. මෙහෙම height එකක් මෙතන ඉන්නේ. මේක කන්දක් පුරන අරන් යනවා. We are going to take this structure into a mountain. So whatever things is going to happen, I imagine what is going to happen. ඔහොම තමයි ප්‍රශ්න අහන්නේ, right? Now I'm going to measure it in in Colombo like this. Now I'm going to take this structure to Nuarelia. What is the change that I can observe? කියන්න එපා. පුළුවන් නම් message එකක් දාන්න නැත්තම් මම තියන්නනේ question එකක් විදිහට. Right, okay.
You can get the break by thinking like that, right? Imagine I am going to carry that to Nuerelia and tell me what is going to happen. What is the change that you are going to observe? I'm going to take the same structure to Nuerelia, right? Okay. Take the break. There is 5-minute break, and let's join after that one. So we can quickly finish these things and go to the hydrostatic pressure. Sorry, there's up thrust, and that is very easy. Then we can go for the questions, right? කොහොමද පාඩමක් pigment ඉවර කරගමු කොහොමද? Right. Okay. Think that and take the break. Only 5 minutes, right? Don't disconnect yourselves. Right, took some time because there was a cold, right? Now, most of you friends, and I think that is coming from your contact. So whatever these new students are asking to come due to this situation, right? So that they are give me calls and all these things. That's why it takes some time, right? Okay. Again, if you also have some, just like I mentioned you earlier, if you have other friends and everyone, ask them to join, especially for revision, right? That is the charges don't change, right? There's no problem, especially because theory class we have almost finished everything, so there are no new things to be discussed in the theory class, right? So what is the important thing is revision. So ask them to join to the revision, and all the revision past lessons are going to be uploaded, but time to time, right? It's going to take a while because there are a lot of gigabytes, right? Not a problem with the data, but it is going to take a lot of time to upload, right? Uploading speed is usually lower than downloading speed, right? So it takes a lot of time. I'm uploading them, right? As some of you have requested theories and I was uploading them previously. Now I will upload them one by one so that they can get them, right? First few lessons are there already. I think first 5 to 6 lessons are there already. The others will also be uploaded time to time, right? So whoever joins, they can get the tutorials are already available and the lessons in the YouTube, right? Okay, now let's move on to the yes. You have given me the answer. Most of you have given the answer. Yes, the height of the mercury level will reduce. Yes, yes, less than in Norway, right? Good. Yes, that is the thing which happens, right? So height changes. So people got used, right? So people got used to give me a second. Pressure. People got used to give the pressure by the units of this height, right? So a popular unit that is used even today is giving the atmospheric pressure by mercury centimeters or milliliters, right? Give me a second. I again. Hello, Ayodhya. Me class එකකින් මම ඔයාලට පස්සේ ගන්නද? හදිසියද නෑ නේද? Right, right. හරි. මම ඔයාලට හරි. Right. Give me a second, right? It is given here, right? Mercury centimeters and mercury millimeters are also used, but mercury centimeters, because when it comes to millimeters, it is more accurate, right? 760 millimeters, you can write it, but mercury centimeters, 76. So if this is at HGCM, right? If this is at Colombo, then Nuvareli it should be 70. Or so whatever number less than 76. That is the way it should happen, right? Okay. I think that is clear for you. Barometer. This is one way. There's another barometer. Aneroid barometer. You don't need to learn the structure, but that what happens in that one is this balloon gets filled, right? According to that one, a gauge is working. Because they are not questioned for the examination. No calculations. Likewise, there are other things, and there are a lot of other methods, right? Mobile, even in the mobile phone now there are barometers, right? A lot of other factors can be used to get the atmospheric pressure rather than this method. But this is the thing which is related to the theories that we learned today, right? Right. Now again, applications of the atmospheric pressure in day-to-day life. I'm not going to draw them very simple. The simplest thing when we are sucking something, that in this one, when you are using a straw, when you are using, what we are doing is we are going to reduce the atmospheric pressure inside the straw. As a result of that, in the diagram nicely it is given, whatever the liquid on the cup gets pulled, right? Now one thing, it is spiral. Which what is spiral? You ask. We don't still know the effect of that. I think no, due to the another one is heavily raining. That's why sneezing, not due to this COVID. Right. If that happens, it's going to be a problem for you, not for me. I'm going to be resting, right? Okay, I'm going to erase this one. So now please think What happens for these Milo and whatever things which are packeted? In this one, this is not going to happen, right? If you have, all of you may have consumed one or thing, two, right? In that one, what happens is, if this is the Milo pack or whatever the pack before consuming, right? When you are sucking that, there is no way to push it like this. So what happens is that packet is going to be squeezed inside. That packet is going to be squeezed inside like this. As Milo is made with tough, what is cardboard, so it is not going to be very much squeezed, but you can see that is squeezing, right? That is due to atmospheric pressure. So in that case, atmospheric pressure is acting on the packet, not on the liquid, right? When you're using a cup here, it happens here. No, it is not still clear, right? Still not clear. What the spiral cube, right? Right. The straw incident, and this one, I think that is somewhat the siphon method, right? In the siphon method, first we will have to drag that one again, right? First we will have to drag this again. This is a YouTube, right? Again we'll have to drag this YouTube. Then what happens is, throughout the inside the tube, what is filled is that liquid, right? So that liquid doesn't allow the atmospheric gases to get enter. If we take the upper, if we take the whatever the container at the upper level, that liquid gets pushed. That liquid gets pushed due to the atmospheric pressure. So as a result of that, that runs through the YouTube bed, goes to the beaker B, beaker or container B, right? These things are very simple examples. And the action of this rubber sucker is also same. When you are pushing something, right? This is good for glasses and whatever shiny surfaces, right? The other surfaces, this fixing doesn't happen properly. That is the thing, right? Rough surfaces, there can be small holes which allows the gas to pass through, allows the air to pass through. If it happens, again the pressure is going to be equal at both sides, right? Again the pressure is going to be equal at both sides, so it is not good, right? If this is the surface sucker, something can be hanged from this one. So when we push this one, what happens is the air from these places gets escaped, right? So then the atmospheric pressure acts on this and this gets fixed. So if we fix this to a rough surface, what happens is there can be small holes, microscopic holes, which again push the atmospheric air inside and the pressure levels become same. So this will drop. Simple thing, right? Is there a place without atmospheric pressure in the world? Oh, right. We can create artificial environments. Those are the places that we call as vacuum. If you can remember the fourth lesson of your grade 11 syllabus, right? Bell jar experiment, we created a vacuum, right? In that one, we can see the, what you call, bell is ringing, but we cannot hear, no air. So in whatever place there is no air, that means that place has no atmospheric pressure. No air means no atmospheric pressure. Very simple, right? Okay. Is there any place without? Right. Then next one, right? A very important topic, that is flotation. We are going to talk about the flotation and upthrust. Right? Flotation and upthrust. Now you may be thinking again. Now we have seen small, say nails, small nails and some pins. When we drop them into water, they get sink. It's sunken in, right? But very large ships with the weight of tons can nicely float. So what is the secret in behind this, right? So the secret is the upthrust. So upthrust means the simple theory, right? If something is floating, if something needs to float on a liquid, not exactly in water, if something needs to float in on a liquid, the requirement is its weight should be balanced by another force which is generated from the liquid. This force is given the name upthrust. Upthrust, right? When something is floating, or if something needs to float, it should match its weight by the upthrust. So upthrust is a force which is generated on the liquid, right? So now we should be able to identify, right, how to increase the upthrust, how to decrease the upthrust. So we should know that what are the factors which decide the upthrust, right? What are the factors which decide the upthrust, right? This upthrust, right? So this is where the Archimedes principles, Archimedes theories comes into play, right? So in Archimedes, what did he do? Let's quickly go to the that practical, right? This practical, that is 15.3.
And 15.3
Yes, if we are in a vacuum, we cannot breathe, right? If we are in a vacuum, අපි මැරෙනවා. ඒකයි when you are going out beyond the space, international space station එකට යනකොට, right? ඊට පස්සේ when you are going to the moon, right? Special kit is there, right? Astronomers kit is somewhat different, right? One thing is to withhold or withstand that pressure. Pressure means no pressure situation actually, right? Pressure එකක් නැති situation එකේ ඉන්න බෑ, මොකද අපි මේ atmosphere pressure කියනකොට අපි එළියට පුපුරනවා, right? We are going to be blasted out, right? So in order to give that pressure and also to function heart and everything, right, there should be pressure. ටින්ටින් එහෙම හඳේ යනවා තියෙනවනේ, ඒක කරන්න බෑ ඇත්තටම, right? You should wear that particular suit, right? And also there is no oxygen supply. Yes, so that we should have whatever mask or whatever thing which provides oxygen. මම දැකලා තියෙනවා මේ උගුළු එහෙම and මේ ළඟදිත් තිබුණානේ international, that is for international space station, right? There was a launch, right, through SpaceX. එහෙම එකක් තියෙනවා, ඇඳුමක් තියෙනවා, right? The suit is changing now, it is becoming very what you call small means the, if you take Neil Armstrong and their suit, right, which they used to go to the moon, it is very thick, right? But now it is getting very attractive, beautiful and thin, right? Easy to wear, right? Okay. Atmosphere එකට ගියාම බෑ එහෙම කරන්න, right? So this practical shows you about the upthrust. In the first case, A, activity 15.3A, if you hang this one, you can see, if you hang whatever let's say wood, right, wood block from a Newton balance, you can see a value, let's say 10 Newton, right? Then what you are going to see is, you are going to push that, right? Situation B, just press that downwards, so that you can see the Newton balance increases its value. Second situation, first situation, let's say 10 Newton. Second situation, press කරනවා යටට, let's say 15 Newton. Next situation, යටින් උඩට press කරනවා, we press from bottom to up, right? So in that one, 8 Newton, අපි හිතමු 8 Newton, the hypothetical values, right? So again, that the D situation, we are going to immerse that in water, right? We are going to dip that in water. Again we can see a reduction in the value. That means value 10 gets reduced. Let's say it is 7 Newton now. With this we can very easily show you that when we dip something in water, an upward force act on that one. ඕකට තමයි ඔය practical එක කරන්නේ. හරි? දැන් අපිට බලා ගන්න ඕනේ force එක කොච්චරද කියලා, right? Now let's quickly go to the activity 15.4. දැන් මොකද කරන්නේ in that one? Right? I'm quickly going through these practicals, right? ඒක කියන්නේ කෝකද නෙමෙයිද? අර ඇඳුමද නෑ ඒක ඒගොල්ලෝ නෙවෙයි අර ඇඳුම නම් අර අලුතෙන් යූස් කරපු ඇඳුම නම් ලස්සන ඒක ඉන්ටර්ස්ටෙලර් මූවි එක I don't know whether you have seen that right interstellar O level ඉවරලා බලන්න එක නිකන් ඉන්නකොට හරි in that one also there was a very nice suit and the new suit is exactly similar to that interstellar movie suit right interstellar that is related to black holes and everything right if you are interested in physics you can watch that one right interstellar that is an award winning movie right the first one activity 15.4 right first image you can see when the block is not immersed there is no dispersion or we can say just displacement right no displacement of water when I am going to dip this half දැන් ඔන්න මම දෙවෙනිට half dip කරලා තියෙනවා and we're going to draw these things අඳින්නේ නැහැ theory නෙවෙයි when we are going to dip this half some amount of water is displaced and it is collected to the beaker when I am fully immersing this again another right few more amount milliliters of water is displaced and collected to the beaker right if I further move downwards there is no change that means zero water in the beaker at A let's say 5 milliliters at B 10 milliliters at C again 10 milliliters at D right D amount volume D right now I am going to measure the mass of the or weight I mean directly weight එකට යන්නේ weight right now what I am going to do is I am going to measure the amount in B let's say in B the weight is 5 newton in C the weight is 10 newton in D the weight is again 10 newton right so with this Archimedes was the first scientist to give that opinion or to give that theory right to find out that theory right so with this we can identify and also with the balance right me practical ගොලු කරලා ඒක මම ඉක්මනට මේ කියන right with the balance we can identify when at the A situation what was the weight at the B situation what is the weight at the C situation what is the weight so what is going to happen if the mass or the weight at A is 15 B is going to be reduced right C is going to be further reduced D equal හරි මේ කාරණා මේ ප්‍රැක්ටිකල් එක මුලින් ඉඳලා ඕන නම් කියන්න මම හිතන්නේ එහෙම නම් ඕන වෙයි කියලා right for anybody මම රිවිෂන් වල නම් කවදාවත් කරලා නැහැ එහෙම theory හොඳටම අප්සෙට් වගේ නම් එහෙම කාටද කියන්න මම නිකන් පස්සේ හරි පොඩ්ඩක් එක්ස්ප්ලেইন කරන්නම් ක්ලාස් එකෙන් පස්සේ හරි ඔය රිවිෂන් එක ගොඩාක් මේක එක්ස්ප්ලেইন කරන්න කාලනාස්ති කරන්න අපරාධ right දන්න නිසා ඔක්කොම right so with that one we can see somehow the upthrust දැන් අපේ ප්‍රශ්නයක් තිබුණේ we had a problem how to find the upthrust so upthrust is equal to the weight of the liquid displaced by this object ඕක තමයි Archimedes කිව්වේ that is the Archimedes theorem right upthrust generated by a liquid on an object is equal to the weight not the mass weight is also a force right weight of the liquids displaced by this particular object that is the Archimedes theorem right with Elon Musk එක්කද යන්නේ මම දන්නේ Tom Cruise යනවා කියලා මම දන්නවා Elon Musk එක්කද Elon Musk යන්නේ නැතුයි මම හිතන්නේ යා රිස්ක් එකක් ගන්න නැතුයි තාම උඩට යන්න right somehow Tom Cruise will go right so the I don't know what the movie Mission Impossible next edition next one or whatever for someone right but we don't know about the Musk situation Elon Musk යයිද නැද්ද දන්නේ right Archimedes principle එක තේරෙන්නේ නැද්ද කියලා මම I hope right because if we are going to discuss all the practical things practical everything it's going to be time consuming but if someone needs that practical please tell me right නෑ yes with his help oh Elon Musk help එකෙන් තමයි යන්නේ right not with him right with his help SpaceX එකේ ඒ මිනිස්සුන්ට නෑ ඉතින් එතකොට වෙන කායින්වත් යන්න බෑ right but Elon Musk will go one day right one day අයියා කවදා හරි when everything is extremely safe just in order to show that it is accessible for the general public Elon Musk will go right okay right right Trishan නැති ඈ දැන් out මට වෙලා නැහැ ඊට පස්සේ right Archimedes principle, is it clear for you? If anybody needs the practical to be discussed, please tell me, right? තාම කවුරුත් දාලා නැහැ. තාම කවුරුත් දාලා නැහැ, right? ඕනේ කියලා, right? I think it's enough, right? So this is the simple, in simple terms, the Archimedes theorem, right? Okay. Then let's quickly, I hope you understood everything, right? And there are some other fully immersed situation, half immersed situation, few there. අපි ඒ ටික questions වලින් identify කරගන්න බලමු. හරි? Right. Now let's go for the questions. Then answers ටිකේ මම ඉල්ලුවට දාන්න ටක් ගාලා answers මේවා කියලා. I want to check, right? Quickly. Right. නෑ නේද කාට? Right. No questions. Now I'm just waiting whether you will give me or you will ask me to conduct the rest, right? No. හරි. Then let's quickly go to the tutorial. අපි quick tutorial එකට යමු. Right. Define the term pressure and name the units of pressure. Very easy. The ප්‍රශ්නයක් නියමිත එළවනවා දැන් ඔය හෙට මෙට යවන messages මට එනවා මේක ඇතුලේ contact request දාලා ඉඳලා අහන විකාර ඔළුවෙන් හිටලා දින හම්බෙච්ච ලාව මේක ඔප්ෂන් එකක් තියෙනවා මට වෙලා නැහැ ඔක හොය හොය ඉන්න නැත්තම් මේ බ්ලොක් කරලා දාන මෙසේජ් කරන්නේ ඔක්කොම අල්ලලා විනාඩියකට right define the term of pressure and name the units of pressure. That is easy. A glass bottle is kept on a surface if the weight of the bottle is 75 newton and the area of the bottom of the bottle is 0.25. Find the pressure exerted on the surface by the bottle. I will do it in the proper way. Proper way means if a question is given like this for the examination, how you should write it, right? ඒක තමයි revision එකේදී important වෙන්නේ. But after that, I am not going to do that one for every question, right? But for every question, you should do in this way, right? Right. A glass bottle or whatever this thing, when you are reading again, as there are new students here, when you are reading a physics or chemistry question, first the thing is we should identify, most of the times that is for an equation, right? First we should identify the equation. As we are in this pressure lesson, no problem, we know the equation is this one, right? But in some questions data is hidden and it is difficult for us to identify the equation. So for any question, when you are reading, while you are reading, this is how to identify the equation. මේව තමයි equation එක identify කරගන්න. හරි එතකොට වෙලාව නාස්ති වෙන්නේ නැහැ බොරුවට කල්පනා කරගෙන ඉන්න වෙන්නේ නැහැ. In the examination you can save a lot of time, right? This is how to identify the equation. Keep on reading, right? A glass bottle is kept on the surface if the weight of the bottle is 75, right? W within brackets you can put F, right? W weight එක කියලා කියන්නේ හැමතැනම it can act as a force also, right? Is 75, right? That's why rough sheets are given. මේවා ලියන්නේ rough sheet එකේ, right? ලියගන්න. question number එක දාන්න ඕනේ නිකන් ලියගන්න, right? ඉවරවට පස්සේ ඔක්කොම ටික කපලා දාන්න. You can cut everything after finishing that question. ඊට පස්සේ යටින් rough sheet එක ඊට පස්සේ ලියන්න. This is how to identify, right? And the area of the bottom of the bottle is 0.25, right? Area is 0.25. In here, you don't need to put the units, right? Find the pressure. P equals question. Now you can see, when you are looking at these variables, you know the equation that you should apply is P equals F divided by A. So just to clearly get this or extract this information, this is called as extracting. A level physics එක කරනකොට මේක අනිවාර්යෙන් කරන්න ඕනේ. නැත්නම් හරි අමාරුයි because lot of information are hidden and unwanted information නා කිය. ඕන නැති information ගොඩක් දීලා තියෙනවා. මේක අහනවා නම් තව information කොච්චර දීලා තිබ්බත් we can assume that safely these informations are irrelevant, right? So we can very easily get the relevant information. මේක මම සාමාන්‍යයෙන් කියලා දෙනවා physics chemistry එකට ආවම, but please remember, right? Okay, then P equals F divided by A. P equals F divided by A. Or you can write pressure equals force divided by area. The equation was identified. Then application. Yes, that is 75, right? 75 Newton with the units divided by 0.25 square meters, right? Then the answer 300 it should be. Right. So this is how to get the equation, application with the units, and final answer and unit. Instead of nm minus 2, you can put Pascal. Pascal කියලා දාන්න පුළුවන්. Right. This is how to get. මේක හොඳට please remember this one, right? Marking scheme කියලා ඕන තරම් ඇහිලා ඇති. This is the marking scheme. මෙහෙම තමයි ලියන්නේ. හරි? Right. For physics and chemistry questions which are related to equations. හැම paper එකකම in every paper, right? Lot of questions are given like this. මෙහෙම තමයි ගොඩක් ගණන් හදන්න තියෙන්නේ. To the calculation, right? So please remember, apart from මේක කරන්න නැත්තේ අපි, this procedure is not followed for this procedure, right? This procedure. MCQs වල මෙහෙම දාන්නේ නැහැ, right? But even for MCQs you should follow this method. මේ ටික හොයා ගන්න ඕනේ. Extracting information is common. මම paper discussion කරනකොට ඔක කියනවා, but as you are writing the papers from tomorrow onwards, please follow that one, right? මෙහෙම තමයි information extract කරන්න, right? මම ඊළඟ ඉඳලා ඔක කියන්නේ ටක් ගාලා ගන්න, right? The pressure exerted by a pile of sand distributed area of 5 meters on the ground 250, right? දැන් මේ එක එක දාන්නේ, but you should apply all of them, right? 250 equals 5 m square. Right. If you have any question, ask me, right? ඉන්නෝනේ ද කට්ටිය? ඔව්. Any question අහලා තියෙන්නේ? ඕ මට ඔක්කොම පේනවා එහෙනම් මේ ප්‍රයිවට්ලි යවනවා මේ මම ඉතින් ඔය බලන්නේ නැහැ හැම එකක්ම හරි යවන්නේ ප්‍රයිවට්ලි එහාට මෙහාට messages නේ එහෙම කට්ටිය it is not a problem, right? It's not a problem whether you discuss or whatever thing, right? ඔළුවේ හිටන් හිටියම මට කමන්නේ after the class, right? After these 3 months this is how things going to happen, right? Whatever this after finishing this examination for you and me both, right? There is no pressure. මටත් pressure එකක් තියෙනවා how to finish these things, right? With on time means before time actually, right? And due to this COVID thing, right, a lot of pressure on me to finish these things on time, but definitely we are going to finish, right? ඔච්චර කාලයට ඒක කිසිම ගැටලුවක් උන්නේ, we are going to finish that one. After that one, that means on the final day also there are no celebrations, no crying, nothing, right? In any of my classes there are no such things, right? It's just a regular class, we finish whatever the things, that is the final class, that's all, right? But after the class, I'm going to take a meeting. That means just a meeting means not a class, right? Just a meeting to discuss the matters on the examination and everything. That is after finishing all the subjects. Most probably after the 30th of January, again for 30 minutes or so, we are going to meet, right? And we are going to discuss about the paper, and I'm going to give you the answers, right? Until then, I'm not going to give you the answers for even for MCQs, right? I'm going to give you the answers, and we are going to have a good discussion, right? On that one. Even in the physical class, that was like this, right? After the class, student come and meet me or visit me, or probably on a class day, on a weekend, right? So just like this, it is easier for us to do that one on online here. I will give you a date. I will provide for that group, right? So you can come, and after that one, you will be removed from all the groups and you will be added to another group, which is the past students of this class, right? Now don't misuse that group, right? Right? You can change the numbers or add others. You can use them for A levels because you will be following the 4 streams, right? Some will go to the 5th one, but it depends on you. But so you can share the past papers, you can share whatever the knowledge that you want, right? Keep the context, right? That's good. You can keep the context. There will be a waste of time. I am going to make a way, or I'm going to provide a way for you to collaborate, for you to meet online, right? Mama group but I'll be staying as admin, right? Right? Later, WhatsApp group, sorry, I will provide you information about the what is called Facebook group, right? Still, I'm not asking you to go for Facebook or to have a Facebook account, right? That is not relevant or not needed for you, right? But that what do you call that collaboration or that friendship is no problem, right? We still are in some groups that we were uh, in A levels, right? When we were doing A levels, we participated for several teachers classes, right? So we have formed groups. WhatsApp group is there, right? And Facebook group is there. Even that sir doesn't know that there is a group with the name of his class, right? His class, the students of this sir's class, like this, right? So we get added and we discuss things, right? Jokes and everything, right? And most of them are met at the university, right? After that, in postgraduates also we meet. Some of the fresh students meet as our students now. Likewise, there's a nice collaboration and there's nice friendships, right? So I'm going to pave the way, or I'm going to make or give you all the facilities to communicate, have this friendship, because you don't see with each other, right? But please wait for until that, right? O levels you are right? එතකොට ඔයගොල්ලන්ට share කරගන්න, you can do whatever the things that you want. දැන් මේක ඇතුළේ පිසුනලා හුවෙන්නේ නැහැ. එම්මෙන් අහුවෙනවා. Right. ඒකල ඔළුවෙන් නිින්දෙන් හැරෙනවා වගේ නියමිත මොනවා හරියක් අහනවා හිටපු ගම. මොකක් හරි කියනකොට right. Next question. Equine question, sir. Right. Write 4 characteristics of the liquid pressure we discussed, right? With the height it increases, it is equal for all the sides, right? Likewise, there were 4 characteristics. We learned those things. You can write them. At a certain location, the depth of the certain point of the lake is 250 centimeters. A very good question. Again, right? The depth is 250 centimeters. First information, right? Find the pressure. P is the question. Exerted by the water at the bottom of the lake at this location. Density of the water is 1000. Rho is 1000. Sorry. G is 10, right? Cubic meter. G is 10. MS minus 2. Not relevant to put the units here, but with this one you can very easily identify that even though this is D, H whatever, this is a height. The important thing here is this height should be given in meters. Height take a meters only. So you should be able to convert, or you should definitely convert. අමතක කරලා 250 දාලා හදන්නේ. ඔතම කරලා ඉන්න ගිහිල්ලා. හරි? h rho g p equals h rho g unit, writing the unit, right? H, you can directly, now you don't want to show this calculation at any point, right? You can directly convert that and put it in the expected manner, that is 2.5 meters into 1000. දැන් මම නිකන් දානවා නැත්නම් අපිට මේ වෙලාවත් යනවා උඩත් මදි වෙනවා into 10, right? 2.5 into 10 to the power 1 2 3 4 pascals. This is the pressure, right? So that you can get, but you should do this all these things. Sorry, mom vela yanisa ikmanta me kiyanne. The depth of a certain region is 2.5 kilometers. Find the pressure exerted at this region by the sea water, right? Now the only thing is pressure, or the density is changed, right? Density is changed. Again, 2.5 kilometers means 2,500 meters. 2,500 meters into 1,050 now into 10, right? What is the final value? Somebody send me the message, right? What is the final value? Podi calculation, right? A vehicle of 1,000 kilogram needs to be lifted using a hoist at a service station. Imagine the vehicle is placed on position B and operator applies a force on the piston A. Calculate the minimum amount of force that must be applied to lift a car, right? Okay. 100, sorry. Question 6 answer. Right. දෙන්නෙක් දැම්මොත් answers දෙකක් දානවා. ඒකයි මම මකන්න තු තිබ්බේ හරි. මොකක් හරි එකක් කරනවා, right. ඔච්චරම අරුදු කරන්නේ. One, two, three, four. 2, 6, 2, 5, 4 dots. Right. Yes. What is the answer? Then you should check. Chanul, you should check your answer. Question number 6 ne අපි discuss කරමු. Yes, 6 චුට්ටක් බලන්න. 2625 is the value. Name it කවුරු 10 to the power දාපු කියලා බලමු power එක හරියද කියලා. 2.6 2.10 to the power 7 නේ. 1 2 3 4 5 6 7. Good, yes. 2.625 into 10 to the power 7 Pascal or Newton meters. Sorry, N minus 2, right? Newtons per square meter. Next one, the equation to make a quick let. This is the one, right? Okay, we calculate කරගන්න. Now you may be seeing, right? මම නිකන් calculate කරන්න කියලා කියන්නේ ඕක තමයි කරන්නේ, right? So the whoever the person who sent me that incorrect answer, your one of you, imagine there is a question which gives 3 marks, 1 mark is lost. බලන්න කොහොමද මට එහෙම වැරදුනේ කියලා. Calculation එකේ වැරද්දක්ද, application එකේ වැරද්දක්ද, equation එක වෙන මොකක් හරි එකක් දාලාද, right? Sometimes conversion may be wrong. මොන හරි වැරද්දක් වෙන්න පුළුවන්, right? This is what happens even in the examination. ඕක තමයි භාගයටත් කරගන්න, right? Let's take the point, the theory, the argument PA equals PB. You can write for the examination also in this manner, right? PA is yes, is the FA. You can put letters, right? Or later you can write whatever thing, but Up to this point, we can write it like this, right? FA, the force that should be applied on piston A, and the related area is 25. Now I'm going to apply centimeters here, right? No problem. PB, the the vehicle is 1000 kilograms, so the pressure, sorry, the weight of that one is 10,000 Newton. That you should identify. Again, you can directly apply here. 10,000 Newton. And area is 500, make it meters, meters, right? No problem. 500 square meters, right? Methanum, you can, this is one, right? And you can do some cancelling off here in order to simplify, some simplification. Then the FA comes 100 into 25 divided by 5. That means 500 Newton, right? In order to lift or in order to generate 10,000 Newton here, we just need to apply 500 Newton here. That's all. Very simple, right? Then after this one, right? If this is an essay question, if this is a structured essay, no problem. There is no other space to do this. If this is an essay question, you can write a statement or just a sentence, right? What they are asking is the minimum amount of force that must be applied to lift the car is the minimum amount of pressure that should be applied in order to lift the car is, and you can give the answer, that is 500 Newton. Right? What is the equipment used to measure the atmospheric pressure? Barometer, whatever the barometer, right? 3 applications of the atmospheric pressure, you know. The atmospheric pressure at the sea level is 76. Taking the density of mercury as 1600 kg, find the the atmospheric pressure at sea level is take the right. Find the atmospheric pressure in pascals, right? Atmospheric pressure in pascals. Good, easy. Good. Again, H rho G, height given in centimeters should be converted to meters. 0. Now I'm going to write it like this, right? Exam papers discussion means like this. Instead of writing 0.76, it is way better and easier for you to write it like 76 divided by 100, right? Easily you can cancel off some zeros, right? Because you don't bring calculators for the examination, so you should be tricky in order to find them, right? Lazy 0.76 decimal points final answer. Not for you, even for me with the examination pressure and everything, right? That's why we do it. Rho 13,600. Yes, 13,600. There units දාන්න මම වෙලා නැති නිසා වෙලා සහ ඉඩත් නැති නිසා මෙතන ඔගොල්ලෝ දාන්න ඕනේ, right? මේක 10. Now instead of putting 0.76, as I have applied 76 divided by 1000, I can very easily cancel off these things, right? Lazy good. 1360 multiplied by 76. I got the answer amount of pascals, right? Find the height of the water column. Very good question, right? Answer quickly, Danbal. For that one, answer. Quickly send me the answer, right? One answer, Sukugim. Very good, very good, very good, very good. Oh, everyone is correct. Yes, very good. a pascal, right? Now what they're asking is, imagine what will happen if you're going to use water. If we put water, this is what is going to happen, right? The height. Now what is going to happen? Even though we use water, mercury, or whatever liquid, the atmospheric pressure in pascal won't change. So this is going to be the pressure, right? So P is 103,360, right? So what they are asking is, what will happen to the height? H is same, rho is now 1000, right? Give me a second. You will water is done. Yes, water. Yes. 1000 into gravity, that is 10. Now what will happen to the height if I isolate height here? 103 divided by, that means cut here 1 2 3, yes, 10.3 meters is the height. Now you can see, imagine, sorry, the amount or the height of the tube that we will have to use if we get a water as the liquid. Water ගත්තොත් එහෙම මේ tube එකේ pressure එක මයින්න අතෙන්දී අපිට හම්බුනේ 76 centimeters, very small, less than a meter. එහෙම තියලා බලා ගන්න පුළුවන්. 10.3 meters means අපිට ඉනිමකක් තියලත් අමාරුයි බලා ගන්න. Right? That's why we don't use liquids like water which has a low density. If somebody needs any explanation about this one, tell me, right? State the Archimedes principle. The weight of the boat is 20,000 Newton. When it is floating on water, its apparent weight means whatever the weight given after the upthrust, right, is 15,000. What is the upward thrust exerted on the boat by water? Subtract the apparent weight by the real weight, right? So it is 5,000. What is the weight of the water displaced by the boat when it is floating on water? So upthrust is equal to the amount of liquids displaced. So there is 5,000 newtons for the 12th one. Right. ඊපස්සේ textbook questions ටිකත් හොඳටම තියෙනවා. පික්මට බලමු. අරගේ questions, if we, right, we'll do something about that. 13th one questions, right. The pressure exerted, textbook questions, the pressure exerted at the bottom of a container due to a liquid inside it is 1500. What is meant by 1500 pascal, right? You can mean it anything, right? Simply different methods, right? Meant by the pressure is 1500 pascals. That means you can write it as Newton meters, and you can say on one, right, on 1 square meter, 1500 Newton force is acting. Right? On an area, okay, you can develop, right? On an area of 1 square meter, a force of 1500 Newton acts. එහෙම කියන්නේ, in order to say that, you should convert this pascal into Newton, nm minus 2, right? Newtons per square meter. Then you can define these things. On 1 square meter, 1500 Newton acts. ඒක තමයි කියන්නේ මේ 1500 pascal කියලා, right? Find the pressure exerted by the mercury column with height of 10 centimeters. Very easy. ඉක්මනට හදලා, right? P equals H rho G H 10 divided by 100 into 10. 1 1 1 1 pascal. Right, good. The depth of the pond is 1.5. Calculate the pressure caused by the water at the bottom of the pond. අම්මෝ මේ වන ලේසි. water density එකම දීලා නැහැ. ඒව ලේසි නිසා. හරි. H rho G. ඔතන නම් දාන්න ඕනේ පොතේ දීලා තිබුණේ මමත් ආයි additionally ඔක දෙන්න ගියේ නැහැ. right? 1.5 into 10 into sorry අපි 1000 into 10. හරි. ඔක 15,000. Answer for the third one එහෙම ගියොත් සමහර කට්ටිය ආය අහනවා ඒක මොකක්ද 15,000 නේ. The depth of a certain point at a sea is 1 kilometer. Find the pressure exerted by the sea water at the bottom of the sea at the point. Right. එකත් 1 kilometer. ලේසි. ගොඩාක් ඒවා එනවා එතකොට ගැටලුවක් නෑ. right? One, two, three, 1, 2, 3, 4, 7. Right. A tank with a length of 5 meter with 3 meter and depth of 2 filled with a liquid. What is the pressure at the bottom of the tank due to the liquid? Right. 4A. It should be changed, right? What I'm discussing is the question given as 4B, right? 4B. It's a separate question actually. There's a tank like this. Nice tank, right? 5 meter with 3 meter, depth 2 meter. 5 meter, 3 meter, 2 meter, right? What is the pressure? Pressure we don't need this one, 2 meter, right? Pressure equals H rho G. 2 meters into rho is 800 kg m minus 3 into 10, right? The answer is 16,000 Pascal, right? Another question. Yes. For the first one, 16,000. Second one, what is the force acting on the bottom of the tank due to the pressure? Right? Pressure equals F divided by A. So F equals P into A. 16,000 into 5 into 3, 50. M squared to M squared should be cancelled off. $240,000. Very good. Yes, very good. You have taken the answers. Good, right? The depth, question number 5. The depth of a reservoir is 1.2 meters. Calculate the pressure at the bottom of the pond due to the water. H rho G. Right? Same thing. 1.2. Yes. Water 12,000, right? 12,000 is the answer for the A part of question number 5. Find the force exerted by on the water. Yes. This is the pressure. Pressure equals F divided by A. F equals P into A. So F equals 12,000 into දැන් මෙතන තමයි වැඩි. හරි. 200 නෙවෙයි. So how to convert this one square centimeters into square meters? Not divided by 100, by dividing by 100 into 100, right? 100 into 100. මෙහෙම ලියන්න. එතකොට easy, right? 1 2 1 2 1 2 1 2 240 newtons. Right. Quickly write it. ලියගන්න එක. This is question number 5, right? Question number 5. Make it චුට්ටක් පොඩි එකක් තිබ්බා. To convert square centimeters into square meters. කොහොමද කරන්නේ? Cubic වලට ගියොත් multiply by another 100, right? එහෙම තමයි යන්නේ. Centimeters තිබුණොත් divide by 100. 5 centimeters divide by 100. Now it is meters. Square centimeters, 5 square centimeters කිව්වොත් 100 into 100. Now it is given in square meters, right? Cubic now, if it is cubic, 100 into another 100, and then given in cubic meters, right? Meters, square centimeters, cubic centimeters. Only aga, done if you don't know this one, this conversion, right? Describe simple experiment to denote that the pressure in a liquid increase when it is increasing the depth, right? Write down a simple experiment to find out, right? Describe a simple experiment to demonstrate that the pressure in a liquid increase with increasing depth, right? You can send me the answers for that one, right? Whatever experiments you can send me, what are the experiments that you wish to show that the pressure increases when the depth is increased. A simple experiment was given, right? Simple experiment was a bottle, like can get a bottle, right? At the bottom, the height is high, so the water is squeezed for a long distance. For a long distance. A bottle, like when you are getting the bottle, this bottle, right, you can remember the simplest one, right? Get a bottle filled with water, so water will be falling like this. But you may have any other creative ideas, so send me, right? I can answer on WhatsApp or whatever, right? Write down a simple experiment to find out whether the pressure inside the balloon is less than or greater than the atmospheric pressure. The pressure inside, all right. Again, you can send a whatever one. Inside a balloon, right? Definitely the pressure is high, right? The experiment, if you can remember, right? One experiment is actually which we did for the Newton's third law. Newton's third law, get a balloon like this, fill it with the air, and just you can release it, so it will be moving, right? Releasing the gas, so pressure is high. Or you can fix that to a thread and release it, so it will be going along. Can use a lot of things, right? It is harder to swim underwater. Right. Right. Archimedes principle. So what the Archimedes principle states, when an object is fully or half immersed in water, right? So not in water, actually, in a liquid, fully or partially, actually, right? Fully or partially immersed in a liquid, the upthrust created by the liquid is equal to the, you can write it on the book, it is on the book, right? But again, one more equal, upthrust is equal to the weight of the liquid displaced by that immersion, right? Archimedes principle, Newton's principle, you should be able to write, right? You should be able to write because they have been direct questions, right? If kelima past papers වල අහලා තිනවා write the Archimedes principle එහෙම. Write the Newton's first law, third law, likewise. Even so, usually the definitions in physics and chemistry we don't buy hard them, right? They are questioned in real world applications, but principles, theories, such things are directly asked, right? A levels වලට නම් එච්චර follow කරන්නේ නැහැ, but for O levels there are such questions, right? කෙලින්ම නිව්ටන් ලෝස් එහෙම අහලා තිනවා අපි ඒ ටියුටෝරියල්ස් වලදී ඩිස්කස් කරා. ඒක නිසා පොඩ්ඩක් ප්‍රැක්ටිස් කරමු. The weight of a piece of metal in the air is 20 Newton. When it is completely immersed in water, its apparent weight is 15. Very easy, right? What is the upward thrust exerted on the piece of metal by water? 20 minus 5, that is 50, right? 20 minus 5, that is 50. What is the weight of the water displaced by the piece of metal which is completely immersed in water? That is again 15 Newton. 15 Newton. Behind the scenes, අන්තිම දවසේ පෙන්නන්නේ behind the scenes කියලා මුකුත් නැහැ. ඉතින් එහෙම nothing to show behind the scenes, right? There's nothing to show behind the scenes in this one. So whatever is going to happen is your lighting is going to be improved, right? Okay. Now as most of it, let's see. Yes, there are a few past paper questions. See whether we can discuss. මෙතනම discuss කරන කමක් නැහැ. අපි discuss කරලා ඉවර කරමු. මම කැමති වෙන දවසක discuss කරන්න කමක් නැහැ. The past papers in the 30th tutorial අපිට එතකොට ඉතුරු වෙනවා 14th tutorial, right? Let's discuss it on the next day. අපි අද මේක ඉවර කරලා දාමු. නැත්තම් චුට්ටයි තියෙන ඉවර කරලා, right? When the block of wood is placed in a liquid, past paper question, first one, it flows with partial immerse. Which of the following is a statement relation to this one? The upthrust exerted by the liquid on A is equal to the total weight of A. Right? This should be correct, yes. Total weight of A. බලමු. තව තියනවද කියලා? Partially correct. The weight of the liquid displaced by A is equal to the weight of the part of the immersed in a liquid. The volume of the liquid displaced by A is equal to the volume of A. The density. Another question. අද එපා කියලාද කියන්නේ පොඩ්ඩක් කියන්න. The density of A is equal to the density of 3, 4 directly. We can take it as incorrect, right? Then the next one, the upthrust exerted by the liquid on A is equal to the total weight of A. Next one, the weight of the liquid displaced by A is equal the weight of the, again question, give me a second, right? Then right. The weight of the liquid displaced by A is equal to the weight of the part of immersed part of immersed a part of A, sorry, part of A immersed in the liquid, right? So the answer A and B, sorry, 1 and 2 are both correct, but the most appropriate one is 2, right? The most appropriate one is 2, right? Question number 2. Again, a very nice question, just to see whether you know few theories, right? As shown in the way, I'm not going to read the question, right? But pressures. So what is the theory that you're going to use? Regardless of the shape, the pressure at the same level of the same liquid is going to be same, right? Different breadths, right? Different breadths means the area is different, but you can see same height, right? Which of the following is correct about the pressure? So obviously the answer is the fourth one. The answer is the fourth one, right? A nice question. The prashna. A situation where a swan with a mass of 1.3 kilogram is still in the water in the pond, yes. What is the upthrust acting on the swan by the water? Right, that is 1.3 Newton. No, in this one, swan is, now they have given it, right? Sorry, no, incorrect. Sorry, sorry. 13 Newton, right? The swan is 1.3 kilogram. Right? It is in balance. It should be in balance. Swan is like this. Swan, right? It is applying 1.3 kilograms means 13 Newton. Now it is right? Still is at still water in a pond, right? That means to be like this, both the forces should be equal or the weight should be balanced. Weight 1.3 into 10, 13 Newton should be balanced by another upthrust of 13. They know that students know this concept, just like in the previous one, collaborator, as it is very easy, 1.3 pick karna. Right. Whatever the time you have, fully consume that. In the examination, total time, double check. Right? In a way to do that, they have given questions like this. Right. In a certain day at the atmospheric is 76. In a certain day, the atmospheric pressure at sea level 76 mercury centimeters and the atmospheric pressure at 10 kilometers above the sea level was 20 right mercury centimeters. Name the laboratory instrument which is used to take the measurements of atmospheric pressure stated above. See how easy they are. Right? Mercury barometer, right? In that one, marks were given for the term mercury because they have given the pressure in mercury centimeters. Right? Mercury barometer. Question is there. What is the answer for the third one? තුන්වෙනි උත්තරේ fourth one නේ අන්තිම එක 13 Newton කියලා උත්තරයක් තිබ්බේ ඒක තමයි. හංසයාගේ බර. 13 Newton. Right? What is the reason for the pressure difference observed above? So what is the reason for the pressure difference observed above? So what should be the difference? When we are moving from sea level to a higher place, the amount of air above the, when we are moving from the sea level to an upper level, the amount of air, the amount of air above the considered level, the amount of air above the considered level becomes low. ඒකයි මම අර පළවෙනි පටන් ගන්නකොටම කන්දක කතාවක් කියලා පටන් ගත්තේ, right? If a mountain is like this, if the atmosphere is like this, right? කොහොම තියෙනවා මෙතන ඉන්නකොට considered level එක මෙතන මෙන්න volume එක වැඩි මෙතන ඉන්නකොට considered level එක මෙතන. Calculate the hydrostatic pressure at a place 2 kilometers deep from the sea level. අපෝ lazy නේ, very easy. බලන්න කොච්චර lazy ද කියලා විභාගෙට අහන්නේ. 2017 examination question. හැබැයි අර විදිහට හදන්න ඕනේ නැත්තම් ලකුණු නෑ. මම ඔක්කොම දාන්නේ නෑ දැන්. H rho G මම ඔයගේ හදපු නිසා 2 into 10 into කොහේ හරි කමන්නේ multiplication එකකින් 1050 21,000 නේ 21,000 Pascal or 21,000 newtons per square meter. That is the answer. What is the pressure exerted by water at a point located 2 meters vertically below the water level in a lake? Now you can see the connection, right? The relationship between the questions. නිකන් ඒගොල්ලෝ මීටර දෙකවත් වෙනස් කරන්න කැමති නෑ අවුරුද්දෙන් අවුරුද්දට. ඒකමයි sorry first one 2 kilometers. ආයෙ වැරදුනා. Same thing නේ. කවුරුත් දාන්නේ වැරදුනම නේ. Multiply this by 1000. next year හරිනේ දැන්ද දාලා තියෙන question එක වැරදුනා. yeah හරි දැන් හරිනේ. ඊළඟ අවුරුද්දේ ඒගොල්ලන් කිලෝමීටර් මීටර් කරලා විතරයි තියෙන්නේ, right? See the relationship, same thing, right? So the answer should be 2000 to 20,000 like multiply කරලා ගමු comment එක, right? 2 into now 1000, right? Into 10 20,000 20,000 2016 question 20,000 is the answer. The weight of an empty bucket is 50 Newton before water is filled to the bucket immersed in water. Filled, the bucket was immersed in water of its volume. The force exerted by the student was 15 Newton. What is the upthrust acting on the bucket in the above condition? Right. The weight of an empty bucket is 50 Newton. Before water is filled, the bucket was immersed in water of its volume. The force exerted by one student was 15 Newton. ये පොඩක් කියවන කි පොඩි ගැටලුව. මොකක් හරි information එකක් miss වෙලා තියෙනවා. හරියට මේ clear නැහැ ඉන්නේ. The weight, yes, before water is filled, the bucket was immersed in water of its volume. Some information is missing. මම බලන්න ඒක මොකක්ද කියලා. මොකක් හරි information එකක් හරි කියලා තියෙන එකක් හරි missing. Whatever the seventh one, let's discuss in the next class. අපි ඊළඟට යන 2008 question එක, right? The mass of a fish is 1.4. මොකක් හරි පොඩි කැලලක් එකේ missing. Apparent weight ඔව් බලමු apparent weight මොකක් හරි එකක් ඇති මම බලන්න question එක. අපි බලමු. The mass of a fish is 1.4 kilogram. The upthrust acting on the fish is 10 Newton. Find the true weight and the apparent weight of the fish, right? ඒක easy, right? 1.5 kilogram, that means the true weight is මම බඳ කරමු හරි ගැටලුවක් නෑ. True weight is 14 Newton. True weight equals mg. So 1.4 kilogram into 10, that is 14 Newton. Apparent weight 14 Newton plus minus meter 10 Newton ne reject karan. Yes, 10 Newton. So that is 4 Newton. Let's see. Figure එක නෑ නේද? Transparent kettle filled with water at which inside point pressure is equal to R, right? Okay, තිබුණා figure එක නේ. මට figure එක දාන්න බැහැ, right? Those two I will recorrect and I will give you, right? Recorrect කරලා දෙන්න, right? Any questions from the things? Now I'm going to remove the mic.
Right. Any questions? So as it is 9:30, we are going to discuss the 13th එක discuss කරනවා. හරි 13th එකේවත් අපි discuss කරේ පස්සේ සතියේදී. Likewise, questions of the 13th tutorial are going to be discussed in other upcoming day. Right? Any question for anybody? Apparent weight is 15 Newton. නෑ නෑ කලින් දාලා තියෙන්නේ. අපි දාන්න ඒක චුට්ටක් බලමු මම කියලා බලන්න. අර කියන T kettle එකක් තියෙන එක T kettle එක මල ගන්න තියෙනවා ඒක right. I will put that. Dance එකත් එක්ක දාන්න right. Any other question for anybody? No. That's the whole question. නෙමෙයි එහෙම ස්මාර්ට් කියලා නෑ කන්නඩි දාන්න එහෙම ස්මාර්ට් නේ S pen එකදී කන්නඩි දාන්න තව ටිකක් මටත් දාන්න වෙනවා. That is not because smart, right? Due to the any of the disorders, right? එහෙමනේ එන මොඩියොත් කන්නඩි දාන්න right? පාර්ලිමේන්තුව බලන්න කී දෙනෙක් කන්නඩි දාගෙන ඉන්නවද කියලා. Right. හරි. හරි නේද? Right, no questions, so I'm going to finish the class, right? As a lot of messages are there also, right? So I'm going to finish the class. So in the next class, I have to upload the tutorial. But upload කරන්න තියෙනවා. මම upload කරන්න එක 16th tutorial. Write the answers for that one and be prepared, right? So then I'm going to finish the class here. Thank you very much for the participation and have a good night. Right.
God bless you, sir.
Right. Good night. Good night.
Thank you, sir.
Thank you, sir.
Right. Good night.
Thank you, sir.
Thank you, sir. Good night, sir.
Right. Good night.
Thank you, sir. Good night, sir.
Good night.